Welcome to the deep dive. Today, we're diving into something really fundamental for our future in space: interstellar navigation. We tend to think of space as just
Yeah.
empty, right? A huge void. But what if that's not quite right? What if it's actually crisscrossed with invisible pathways, sort of like cosmic currents carved out by gravity, magnetism, maybe even stranger things like dark energy? So, the big question we're tackling is this: what if getting around deep space isn't just about bigger engines, but more about, well, understanding where these currents are and how to use them? We'll be looking at this idea of Starpath beacons, theoretical systems, basically navigation markers designed to map these gravitational highways, maybe even quantum routes or, wormhole shortcuts if they exist. Our mission today: let's try and find those hidden maps, the ones written in starlight.
Exactly. And, this isn't just some far-off sci-fi dream. It really gets at a very practical, very profound challenge. Real interstellar travel. It's
Hmm.
not just about speed. It's about navigating an environment that's, frankly, way more complex and dynamic than we usually picture. Finding some kind of inherent structure out there, something to guide us, that would be revolutionary. It could completely change how we see space, not as empty, but as navigable, structured. Think about what that enables: self-sustaining colonies, efficient supply lines, maybe even migration, all by working with the universe's own layout.
That's a huge shift in thinking. Okay, let's ground ourselves a bit. Navigation.
Yeah.
Here on Earth, we've got GPS, super precise, satellite network works great, but the moment you get, far from Earth, that's gone. So what do we actually use now for deep space probes? It feels a bit like flying blind sometimes.
It is compared to GPS, yeah. We mostly rely on distant signals like radio beacons from Earth,
Hmm.
or we calculate position based on known objects, stars, pulsars, that sort of thing.
But why is it so much harder out there? What are the specific hurdles?
Well, several big ones. First, there's light speed lag. Signals just take too long to travel back and forth. By the time you get positioning data, you've already moved significantly.
Hmm.
We've got relativistic effects. At high speeds or near massive objects, space and time themselves get warped. That distorts measurements. And of course, gravity itself. Everything's pulling on everything else. Planets, stars, black holes. It constantly interferes with your trajectory. Put it all together and getting really precise positioning, it's incredibly difficult with current methods. It really shows why we need something more than just maps. We need to find or use some kind of inherent structure within space.
Right. So it's not just about seeing far, it's about knowing reliably where you are and where you're headed in this constantly shifting environment. That really is a fundamental roadblock for, well, any serious long-haul space travel. But this idea you mentioned that space already has roads, that's pretty wild. You're talking about these gravitational tubes or Lagrangian coherent structures, sometimes called celestial autobahns,
That's the concept, yes.
formed by the gravity of planets, moons, the sun interacting. Is this like solid science?
Oh yes, it's based on solar orbital mechanics. Research, like from Ross and others back in 2006, has mapped these out within our solar system. They really exist.
Okay, so how do they actually work, these pathways?
Well, they connect special locations called Lagrange points. These are spots where the gravity of, say, the Earth and Sun balance out. So a spacecraft can just kind of hang out there using very little fuel.
Okay, stable points.
Exactly. And between these points, there are these low-energy transfer orbits. Think of them as pathways. They're not fast. Mind you, take months, years even. But the beauty is they use gravity assists, like slingshots, to move things along the path. So they require almost zero fuel once you're on them. It's fascinating, really, using the natural structure of space for efficiency, making things that would be hugely expensive, fuel-wise, almost free.
Incredibly efficient. And you said these aren't just theoretical, we're actually using them now.
We are. NASA's Genesis mission, which collected solar wind particles, used these pathways. And the James Webb Space Telescope, its position at the Earth-Sun L2 Lagrange point, reached via one of these low-energy transfers.
Wow. So real-world proof.
Definitely. And now imagine scaling that up. Think beyond our solar system. Think galactic scales. Maybe massive things, neutron stars, binary systems, black holes, create even larger gravitational networks, shaping routes across the galaxy that we could learn to, well, ride.
Like cosmic surfing.
Sort of, yeah.
Yeah.
Understanding these autobahns could open up missions we can't even dream of now, just by tapping into how the universe itself is structured.
Okay, so if these cosmic currents, these highways, are real, what's next? How does a spacefaring civilization actually use them reliably? What kind of infrastructure would that take?
Right, that brings us to the idea of Starpath beacons. These would be essentially navigation markers, signposts placed strategically along these gravitational paths.
So like cosmic buoys.
Kind of. And they could take different forms, maybe small autonomous satellites parked at those Lagrange points, broadcasting signals. Or we could use natural phenomena, pulsar-linked beacons, for instance. Some pulsars, especially millisecond pulsars, spin incredibly regularly. Their pulses are like perfect clock ticks. They could act as natural GPS anchors, galactic lighthouses.
Hmm.
Becker and others explored this idea.
Pulsars as lighthouses.
Yeah.
Interesting. Any other ideas?
Well, maybe neutrino pulse systems. Neutrinos aren't affected by magnetic fields, so the signals would be very robust. Or looking further ahead, maybe AI-driven networks, nodes that constantly sense the local space-time curvature and share that data in real time. And then there's the really speculative stuff, like maybe a network of quantum-entangled satellites for potentially instantaneous synchronization across vast distances, though that's still very much in the realm of theoretical physics.
Okay, so let me see if I've got this. A Starpath beacon system, whatever form it takes, would need to do a few key things. Map out these gravitational corridors,
Yes.
provide super precise timing and location data, adapt to the fact that stars move, space warps, the universe expands.
It has to be dynamic, yes.
And eventually all these beacons would link up into some kind of huge interstellar positioning system, an IPS.
Exactly. That's the vision. And think about the bigger picture here. This isn't just for explorers. Imagine interstellar trade routes, or coordinating rescue missions spanning light years, or even, down the line, organizing large-scale migration between star systems. It's really about building the fundamental infrastructure needed for humanity to become a truly interstellar species, making deep space travel not just a one-off possibility, but potentially routine, predictable.
That really does shift the perspective. It's not just about getting there, but about building the roads.
Okay, let's push the envelope even more. Beyond these, let's call them classical gravity routes, what about the more exotic ideas? You mentioned shortcuts. Are there other, maybe faster ways the universe might be connected?
Yeah, we're definitely getting into the more theoretical frontiers of physics. Take wormholes.
Right, the classic sci-fi shortcut. Yeah. Now, if, and it's a huge if, they exist and are stable enough to traverse, they'd have specific entrances and exits. We might need beacons to mark those points, or maybe we could learn to detect their unique gravitational signatures.
Okay, what else?
Well, there's string theory. It suggests extra hidden dimensions. If that's true, maybe space is folded in complex ways in those dimensions. You could potentially have corridors through this hyperspace that act as shortcuts, bypassing the distances in our familiar three dimensions.
Like hyperspace roads.
Kind of, yeah. And then there's dark matter. Still don't know what it is, but some theories suggest it might flow in vast rivers across the cosmos. If so, maybe these flows influence how regular matter moves, and perhaps we could chart them by looking for subtle distortions in light, like Gruber and others have suggested. It's all pretty speculative, but intriguing.
Mind-bending stuff. But it seems like the common thread, whether it's gravity tunnels or wormholes or dark matter rivers, isn't about brute force. It's not just bigger engines. It's about aligning ourselves with how the universe is already structured, finding the path of least resistance.
That's exactly it. Instead of just pushing through space, future travelers might learn to move with space.
Like surfing those cosmic waves you mentioned earlier.
Precisely. And this brings up a really interesting point. What other fundamental forces or structures are out there that we haven't even grasped yet, let alone harnessed? Advanced AI might be key here, helping us model what you could call the gravitational harmonics of the universe, figuring out these complex flows and resonances. It's about listening, really, listening to the universe's design.
So as we wrap up this deep dive, the big takeaway seems to be this. The galaxy isn't just empty space. It's dynamic. It's interconnected, like a giant web that's stretched, vibrating, and maybe even whispering directions if we learn how to listen.
I think that's a great way to put it. And those Starpath beacons we talked about, the ones we might build tomorrow, they might be more than just navigation aids. They could become, in a sense, the very bones of a future interstellar civilization, the framework that lets humanity safely cross the darkness, following paths shaped by gravity, light, and, well, logic and geometry.
So here's a final thought for you to take away. Think about the stars. They don't just shine, do they? In a way, they're already pointing the way, marking the gravitational landscape. What other fundamental principles, what other whispers from the universe are out there just waiting for us to notice, waiting for us to understand and maybe use in ways that could completely redefine travel and maybe even what it means to be connected across the cosmos? Thank you for joining us on this deep dive.